Day so far. This talk is titled Networks in Flux, and I'm Dr. Pete Maynard. Let's start by reviewing the outline of this talk. First, an introduction to who I am and what I do, followed by a summary of 5G network slicing.
Welcome back to our technical talk session. So the next session is from Peter Maynard. Peter has a PhD in critical infrastructure security from Queen's University Belfast, where he developed and performed novel attack on industrial control systems. He spent a while hunting ICS malware and investigating targeted intrusions. Currently, he works on developing novel root of trust mechanisms and lightweight authentication cryptographic protocols for machine-to-machine networks. Unfortunately, yeah, it's so he's had a medical or an emergency, and he cannot. He just messaged us that he's not able to attend at the beginning of the talk. So, like in Niels's talk, if he comes in later, we will have him at the end to answer any questions. But meanwhile, uh, yes, you can tune into the recording of his talk. And this one, I assure you, has louder volume, louder playback volume, so that should not be a problem. So I will leave it to so I'll leave the stage and start the talk.
This talk is titled Networks in Flux, and I'm Dr. Pete Maynard. Let's start by reviewing the outline of this talk. First, an introduction to who I am and what I do, followed by a summary of 5G network slicing. Note I'll focus on 5G networking, not the radio technologies. Then, how automotive teleoperation may utilize such networks, following up with a review of the current security models. That's where I'll introduce zero trust architecture and propose a method of deployment, followed by reflection. So as I mentioned, my name is Pete Maynard. I am a senior security analyst at Angoka, where we work on a number of projects ranging from in-vehicle communication to securing UAVs, unmanned aerial vehicles. Primarily, I focus on performing threat analysis of different use cases and attempt to increase their resilience by deploying zero trust approach. We'll get into more detail on what that is later. In another life, I've worked as a senior research engineer at Queen's University Belfast, where I worked on developing an NDN testbed for industrial systems. So NDN is named data networking, and it is a clean slate protocol designed to replace IP. Even longer ago, I worked as a research fellow at CSIP, Center for Secure IT, where I did a PhD titled Methods for Modeling and Detecting Network-Based Industrial Control System Attacks. So as part of that, I analyzed a lot of intrusions into industrial networks and attempted to derive a set of common features throughout them. Network slicing within 5G is a paradigm that allows the sharing of the same physical infrastructure to provide different services to different end users. This is to address the wide variety of use cases for mobile networks. Since each slice can be configured via software and on demand, it can also provide different functionalities, such as low latency, high throughput, reliability, and isolation. In this diagram, we can see the following sections. At the bottom in grey is the physical public infrastructure, consisting of the cell towers, backhaul routing, edge clouds, and core mobile network systems. Second from the bottom, in red, is the first virtual slice. In this example, it is designated for use of IoT devices. Now this slice may be owned and managed by a leading IoT manufacturer. We can see that the layer requires a subset of the physical infrastructure and not the whole lot. So it's a similar story for the top two slices, which are designated as healthcare and mobile broadband. So for healthcare, they may require a low latency and high availability connection if they're doing remote operations. However, for the mobile broadband slice, they may just require high throughput. So each of the slices are managed by end users, and they all rely on the physical infrastructure to provide their service. This means that each of the slice end users need to manage their own security. The infrastructure provider may offer them to use one of their managed security services, or they can outsource it to whoever they want, or nobody. They may assume that it is secure by default. So that's a quick overview of network slicing and some of the features and considerations when using 5G. So in this example, we have an autonomous taxi service. The taxi company needs to issue routes to the vehicle using a taxi application, shown in the bottom right, and the vehicle will drive itself there, someone will get in, and it will go to its destination. No driver, just get in. In our use case, we have a remote teleoperation of this vehicle. So while it is driving on its own, there are situations where it cannot decide what to do. It has to defer to a human. So that's where the teleop command and control comes in, so something like the top right. And so the operators will be notified of a request for help when the vehicle is stuck. And then they'll be provided with telemetry data such as video, LiDAR, and then they can take the appropriate action. For the system to be deployed, each of the services are provided by different end users and will be using different slices. So for example, a mobile broadband slice, which is our everyday broadband we use, wireless broadband, so your mobile connection, will be the taxi application, the mapping data to the vehicle, and any media. So you're sitting in the car, you will want to watch a video, a film, whilst you're going along. So all that will happen over that type of slice. There could be another slice for the local council, where the taxi will pay its fines, if it gets any fines, and make sure that it's up to date with its correct permits. And then finally there will be the teleop provider slice. We want that on its own. So not only will each slice be on its own, not only will the services be on separate slices, each of the services require different functionality. So for example, the teleop command and control, they will require low latency. They don't want to have to send a command turn here and then 10 minutes later it turns. Need a high bandwidth for the vehicle entertainment system. You need good coverage. It's no good driving out into the middle of nowhere and then it gets stuck and you can't control it. And you need to have confidence in the system. The taxi application, or the people who are running this taxi service, they want to know that they can trust this, trust what's going on. So what we've been seeing is that teleoperators are not confident in the existing 5G systems because they don't meet these requirements. And this is resulting in them falling back to running their own private networks, which can't scale. If every taxi service deploys their own roadside units, RSUs, we would have tens of physical devices on each lamppost for every taxi company. Not only that, but all the previously isolated slices are all going to the same vehicle, removing some of the benefits of slicing, which we wanted in the first place. So while they all are running on their own separate slices, some may use the same one, some definitely using their own, at the end, they're all going to the vehicle. So traditional security models. By design, 5G network architecture is more secure than the previous ones, such that it includes multiple security methods, such as trust levels from various network access, for example, users, application, service-based. And they also have appropriate authentication, authorization, and key agreement protocols for device-to-device, as well as network slicing. However, these security models are built around the idea that once a device has identified itself, and proven to be who they say they are, their trust is not questioned again. So in this example, once a device, an orange box on the left-hand side, is authenticated, it will have access to all the devices within that slice. This becomes more interesting if we consider the physical infrastructure. This problem now affects all the slices which operate over this infrastructure. While it's much better than it was before, at least we can restrict the level of trust to a specific device and keep them isolated within a slice. However, in our taxi example, we know that a device will span multiple slices. So, did mention this earlier. I said I would explain it a bit more. So, zero trust architecture was designed to address the problem of how to trust a device over an untrusted infrastructure. And this can be realized in a few principles. So the first principle is zero trust. We assume that all assets are considered untrusted, even if they're located in a known safe location. So what does that mean? That means we don't trust a device even if we know that it's in a data center. It's got cameras, it's got fences, it's got guards. Yeah, it's a safe location, but we still don't trust it. Second principle is of least privilege. So when access is granted, it'll be for a limited time and with the least amount of privileges possible. And third, integrity checking. All assets are continuously checked for anomalous events in real time. So what that means is if you have a known vulnerability, you haven't patched your system, you're not going to be given enough privilege to perform your task. You're going to have to update before you can do that. So, if we apply the zero trust model to our use case, we get the following. First, zero trust. Well, not quite. We reduce the level of trust between devices within a slice. Whereas before, if a device is allowed on the slice, it's trusted. So now we reduce that. Secondly, least privileges. We improve the level of slice isolation by limiting access down to each individual based on what they're requesting. So for example, we would restrict the vehicle on the mobile broadband slice so that it may only ever access Netflix, so it can stream films to its passenger. That way the passenger can't get bored while driving and mess about with the entertainment system and watch something else. Can't watch Disney Plus. So thirdly, integrity checking. We get verification, continuous verification, that each device has not been compromised. It's fully patched, and we have some insight into what's running. We can be sure that, if there's a known vulnerability in there, it won't have access. So we can be sure that everything that's running is up to date and has, to as far as we can possibly say, no vulnerabilities. So this should address some of the concerns that teleoperators, operators of teleoperation, have with these 5G networks. So, what are your thoughts? We've defined a set of teleoperation requirements, along with some of the operator concerns. So, requirements are low latency bandwidth, and the concerns are lack of coverage and confidence in the slicing and the security of the system. We've proposed a zero trust solution. Now, the IT industry knows that it works in enterprise environments. That's where the idea came from. And we know that it works in in-vehicle communications because we've done it. We've deployed a zero trust approach to in-vehicle communications. Does a zero trust solution apply to this scenario that we have discussed today? Are there alternatives? Maybe the answer is to have smaller slices. A slice for each vehicle and have them managed by the taxi company. Is that possible? Can the 5G infrastructure spin up a slice like this on demand, or maybe we're overthinking it, and the current solutions are fine. Well, that's the end. Thank you very much for your time. I hope it was interesting. If it wasn't, email me and complain. If it was interesting, email me and let me know. So that's p.maynard@angoka.io. So I was Dr. Pete Maynard, and thank you again.
Okay. Yeah, so unfortunately, Dr. Maynard could not make it to the conference. So, like I said, he has a medical emergency and was unable to attend. If you have any questions, like he mentioned his email address, please do reach out to him directly. At this point, we will be closing down this session. The next session will start, which is a keynote on edge computing and automotive security. Will start at 14:05 German time on the main stage, stage one. Meanwhile, I would encourage you to use the networking lounge to network with your other attendees. Uh, yeah, hope you enjoy the rest of the conference. Thank you for attending.